Hello Algebra 1 students, welcome to the start of section 8-1 identifying quadratic functions. Quadratic functions in the standard form are given by the equation y equals ax squared plus bx plus c, where a, b, c are constants, are number, but there is very important condition: a doesn't equal 0. If a cannot equal 0, because guys, if a equals 0, this term gonna disappear, and if this term disappears, it is not a quadratic function anymore. So a doesn't equal 0, but b and c might equal 0, and this is what happens in a parent quadratic function. Y equals x squared is called a parent quadratic function. The value of a is 1 and the value of b and c are zeros. This is why the second and the third terms disappeared and we only have y equals x squared. Guys, the graph of the quadratic function is called the parabola. We call it parabola, and this nice curve is a parabola. This is the graph of the parent quadratic function. The graph of the quadratic function, or the parabola, is made up of two symmetric parts, right part and left part. They are symmetric around the line in the middle. This line, the y-axis, is called the line of symmetry, and this tip head of the parabola is called the vertex of the parabola. Parabolas are around us in real life, guys. Starting from a basketball throw, it's a parabola, and McDonald's logo, it's double parabola, and even the dolphin jump in any aquarium, it's a parabola. Parabola are around us. The first skill you need to learn, guys, how to recognize a quadratic function from a table of values. If you're given a table of values like this one and you need to identify whether this table represents a quadratic function or not, there are two conditions, guys. Condition number one, it should be a constant change in x values. Notice the following, guys. If you subtract 1 minus 0, it's 1. 2 minus 1, again it's 1. 3 minus 2, 4 minus 3. So there is a constant change in x values, and this is condition number one. Condition number two is kind of strange condition, because when you find the differences of y values at the beginning, you will see there is no constant differences. 1 minus 0 is 1. 4 minus 1 is 3. 9 minus 4, 5. 16 minus 9, 7. So guys, don't get scared because the first y differences are not constant. Just be patient and try the second differences. 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is also 2. So what is the second condition to be a quadratic function? For any set of data to be a quadratic function, the first condition, there is a constant change in x values. The second condition, there is a second constant differences of y values. Not the first differences, but the second differences. Take this example. In example number one, guys, we're going to identify quadratic function from a given table or a given equation. Look at this table, guys. We're looking for a constant change of x values and the second constant differences of y values. When you start subtraction, start from the largest to the least value. So 2 minus 1, it gives us 1. 1 minus 0, it's also 1. 0 minus minus 1, it's 1. Minus 1 minus minus 2, it's going to be minus 1 plus 2, it's also 1. So guys, condition number one is okay. There is a constant change of x values. Now we're looking for the second differences of y values, but we have to get the first differences at the beginning. 7 minus 0 is 7. 0 minus minus 1, it's going to be 1. Minus 1 minus minus 2, it's going to be 1 again. Minus 2 minus minus 9 is going to be minus 2 plus 9 is going to be 7. So guys, we don't care about the first differences, but we care about the second differences of the output values. If they are constant, it's a quadratic function. 7 minus 1, it's 6. 1 minus 1, it's going to be 0. 1 minus 7, it's negative 6. Guys, it is not a constant change. So this table of values, this set of data, doesn't represent a quadratic function. So my answer is not quadratic. Not quadratic. It is not quadratic. It is not quadratic function. So guys, what is the reason why it is not quadratic? Because the second, there is no constant second differences of y. The second differences of y values are not constant. They are not constant, guys. Look at this equation in part B, y equals 7x plus 3. Guys, definitely this one is not a quadratic equation. What is the reason? Because if you compare this one, you will find it is not in the form, not quadratic. It is not quadratic. Definitely it is not quadratic. What is the reason? Because this one is not in the form, not in the form. Do you remember the standard form of quadratic function? Y equals ax squared plus bx plus c. Guys, there is no x squared term, and this is the most important condition to be a quadratic function. Actually, guys, this function is a linear function. You studied linear function before, and it is represented by a straight line, not by a parabola. The last part of this example, y minus 10x squared equals 9. Guys, notice that y is not isolated. We need to isolate the variable y at the beginning in order to get this equation written in the standard form. So to isolate the y, we plus 10x squared to both sides. 10x squared. So these two terms cross out each other, and now y is isolated and is equal to, when you write this side, guys, you need to write it in the standard form. You start from the largest power. So the largest power is 10x squared plus 9. What do you think, guys? Is this equation represent a quadratic function? Yes, absolutely yes, it's a quadratic, yes. What is the reason? It is written in the form y equals ax squared plus bx plus c. What are the values of a, b, and c in this equation, guys? A is the number in front of x squared, it's 10. In this situation, guys, in this equation, there is no x term. It means b equals 0, and c is a constant by itself, is equal to 9. So part C, this equation represents a quadratic function. Another skill, guys. The second skill you need to learn in this part is how to graph a quadratic function. We given a quadratic function y equals 2x squared, and we need to graph this quadratic function. So guys, we need to create a table of values. I advise you to start from some negative values, and you need to represent some positive values. So you may start from -2, -1, 0, 1, 2. And the reason is because the parabola is made up of two parts, and you need to see the two parts are represented. So you need to represent some negative x values and some positive y values. Guys, if you insert the -2 in this function, it's going to be 2 times -2 squared. -2 squared going to be 4. 2 times 4 is 8. If you insert the -1, it's going to be 2 times -1 squared, it's going to be 2. 0 gives us 0. If you insert 1, it gives us 2. If you insert 2, it gives us 8. And please notice the following, guys. If you compare the first output value to the last output value, you will see they are the same. The one before, like the one before. Why is that? Because of the symmetry between the two parts of the parabola. Only one point is unique. This is definitely the vertex of this parabola. Now, guys, let's start graphing this parabola. The first point is -2, 8. -2, 8 is just right here. negative 1 and 2, negative 1 and 2, another point to the left, and 0 comma 0, this is the vertex of the parabola in the origin point. 1 and 2, 1 and 2. See guys, this is the symmetry I'm talking about. For every point to the left there is exactly corresponding point to the right. 2 and 8, 2 and 8 is just right here. Guys, when you connect these points, don't use a ruler because this is not a linear function, this is a parabola, so it's a curve. Be flexible when you connect the points and try to make the two parts are symmetric. As you see guys, it's a very nice parabola. It's made up of two parts, and this is the line of symmetry and this is the vertex of the parabola. Another part guys, graph the quadratic function y equals negative x squared. Again guys, you can do the substitution mentally or you can use your calculator. There is a table mode in your calculator. You can write down the function y equals negative x squared and you enter the start point and the end point, and the calculator gonna give you all the output values. But if you are fine with the mental math, you can do mental math. Guys, negative x squared, it means negative times negative 2 squared. Negative 2 squared gonna be 4, but there is a negative sign waiting outside, so it's gonna be negative 4. I expect the last value to be negative 4 as well because of the symmetry. Guys, let's do that. Negative times 2 squared, it's gonna be negative 4. This is what I expected. If you insert negative 1, it's gonna be negative 1. If you insert 0, it's gonna give us 0, and of course this point gonna be negative 1. You can do the substitution in details. Now let's graph negative 2, negative 4. It's right here. Negative 1, negative 1, another point. The vertex is 0, 0. Guys, not every time the vertex is at the origin. Sometimes it is, sometimes it is not. 1 and negative 1, this is a corresponding point to the right. See the symmetry guys. 2 and negative 4, 2 and negative 4. Now let's start connecting our parabola. It's a curve. It goes forever. Not because we choose 5 points, this is the only points. There is a infinite number of points in this parabola. We just choose 5 sample points. So guys, this is the parabola. I went far this time, so I need to be more accurate. Let me erase this. I need to erase this and start over. So now guys, this is the other part of the parabola, symmetric parabola, and our parabola this time is downward. In the first part of this example, it was upward. Some parabolas open upward, other parabolas opens downward. See you in the next part of this section. Study well, practice well. See you soon. Bye.